Okay, we're going to talk about 3.2, and we're going to talk about objects on an inclined plane, which these problems get to be a little tricky, but I believe in you, and I think you're going to be able to solve these. I'm going to throw you right into the deep end with this problem because it's pretty tricky, but I feel no guilt because I know you're going to be able to swim and you're going to be okay. So here we go. A crate of mass 30 kilograms is at rest. So if it says at rest, it's in equilibrium, and that's your first cue as to what to do. On a ramp which slopes at an angle of 18 degrees. Step 1, draw your triangle. Always do that first. And now we've got to think about the mass, and it's 30 kilograms. Well, what is the weight then? We know the weight. We draw it this way. We're drawing a free body diagram right now. The weight is going to be 10 meters per second squared is its gravity in Cambridge, whatever. So it's 300 newtons. All right, we've got that set up. So always start with this. And now we're going to continue with the problem. So I can't remember where I left off, but to the horizontal. So to the horizontal, oh, I left that out. But 18 degrees to the horizontal is this, all right? That's fine. It is prevented from sliding down the ramp by friction. We haven't really talked about friction. They kind of jump into it in the book. But I'm gonna go ahead and draw this crate. I'm not gonna put a lot of details in because we don't care about details. What we care about right now is numbers. And where's the friction happening? Like, what if you put a box or a crate in this instance on a ramp, what's it gonna wanna do? Like, what's the tendency? Of course it's gonna go down. It's like if you go on a slide, you're gonna go down. What prevents it from going down? Friction. What direction is friction going in this instance? To keep it still, it's at rest. So friction is going up. So you've got to draw this diagram this way. So we've got frictional force. We've got another force that we left out, and that's normal force. And normal force is always going to be R. It's going to be, hopefully. Anyway, it's going to go in the same angle as where this ramp is. So it's going to go that direction. It's not going to go straight up because it's on a ramp. All right, so what I'm going to do is continue this. I'm going to make a right triangle here. And this is where your mind might be blown, is that this is a right angle. So that makes this, and I messed up, I should have made this triangle bigger, but that's 18 degrees. This is a right triangle, and this is 72 degrees. Let's go back to the question then. We're trying to find the frictional and the normal contact force. We're trying to find R, and we're trying to find F of F. That's an F. Okay, we're trying to find that. So these forces are opposing. So if I find this, then I find this. It's an equilibrium. It's at rest, like I said before. So we can find this by finding this. And to find that, we can use the angle measure, we can use weight, and we can use this side. So R is equal to, and this is when I want you to think back to when we learned about SOHCAHTOA and so forth, and just, the simple trig, they're not simple, but the trig, the right triangles. The basic trig that we learned. Okay, so 300, we're going to use this angle. We're trying to find out what this side is, the length. But in this case, it's the force. So we're going to say 300. And what trig function are we going to use? Sine, cosine, or tangent? Well, this is adjacent to 18. So we're going to say cosine of 18. Okay, so we found that's 285 newtons. Again, we found the normal contact force because they're opposing forces, and now we're going to find the frictional force. And I write it this way, your textbook writes it differently. I don't care, I'm too stubborn to change, so I'm going to stick with my way. So the frictional force is equal to this force. So no problem. We've got weight coming down 300 newtons. So we can say is equal to 300. And how do we want to get to this side? We want to use the sine. So we're going to use sine of 18. And we're going to get 92.7. So the frictional force is equal to 92.7 newtons.